So let's look at this problem. We have this 50 kilogram reel that has a radius of gyration about its center point O of 300 millimeter, and it is released from rest, and it actually rolls on this rope. And we need to determine its angular velocity when its center O has traveled 6 meters down this smooth inclined plane. So as soon as you see the word smooth, you know that you do not need to consider friction in this problem. Therefore, this is the initial state, so state 1. So for the final state, this reel has rolled down and its center has moved down the hill by 6 meters, which means that vertically, the distance, the vertical displacement is a 6 meters times sine 30 degree. And that is the displacement we're going to use to calculate the work done by its weight. And in this problem, because we do not need to consider friction, the tension force in the cable does not have any displacement, therefore it does not have do any work. The normal force never does any work. Therefore, weight force is the only one that does work. So we can set up our principle of work and energy equation. So the initial kinetic energy plus the total external work done to the system during this process equals to the final kinetic energy. In this case, the reel is released from rest. Initial kinetic energy equals to 0. And we said that the work is only done by the weight, which equals to 50 times 9.81, that is the weight force, times its own displacement, which is the vertical displacement here, 6 meters times sine 30 degree, and that is evaluated to be 1471.5 in the unit of joule. And that equals to the total kinetic energy T2, which for general plane motion, this is the general plane motion. The reel is doing general plane motion. It is not rotating about a fixed axis. Therefore, the general equation is 1/2 m times vg squared plus 1/2 ig times omega squared. But for general plane motion, if we can locate its instantaneous center of zero velocity, then this equation is 1/2 times IIC omega squared. So IIC can be determined by IG plus mRg squared, which is parallel axis theorem, and IG can be determined by the radius of gyration, which is mko squared plus mRg squared omega squared. So we know what KO is. We need to find out RG. In other words, we need to locate the instantaneous center of zero velocity. Because this reel is rolling on this rope, therefore, at this point, the point of contact with the rope, this is where the linear velocity is 0. Therefore, this is its IC. And RG, which is this distance right here, from the center of gravity to the instantaneous center of zero velocity, that is 0.2 meters. So with all that, now we can plug the numbers in. We have 50 times KO is 300 millimeter, therefore that is 0.3 meter squared, plus 50 times RG is 0.2 meter squared omega squared. So this equals to 3.25 omega squared, which equals to 1471.5 joule. So from there, we can evaluate omega to be 21.3 radian per second. And that is the angular velocity of this reel when its center has traveled 6 meters down this inclined plane.